No, it's reagent quality. All right, I don't know, I just can't see it on the thing there.
Reagent probably, in that sense, probably we'll say, because you get reagent, technical,
All right.
whatever.
Yeah, you can get different things, right, depending on the purity. Okay. How are we good? So how do they go about making it? How do they go about purifying it? Well, the way to do it is they distill it. All right. Which this is a section in the next chapter, but since we're talking about alcohol, let's go with it here. So they put this mash, they call it, in here, which that's a whole big fermenting mess. Okay, all kinds of solids and corn and just God knows. But it's got alcohol in it too. And then what they will do is they will start and they will heat this up. Okay, and then they will pass it through an apparatus like this. Now this is how they're going to do it in the laboratory, right? Okay. Where this is a tube inside of a tube. Now what that means is you can put water in here and water will come out here. And it will absolutely fill this whole entire thing, except the center of that tube is not going to be wet. What's the purpose of the water? To make it cold. Are you with me? So the purpose of the water is to make this tube cold. Because as you're heating this up here, there's a thermometer in there. So what happens is, and this is what's called a simple distillation, what happens is there will be steam that starts to come up in here. And then all of a sudden, when it hits this cold thing, what does it turn into?
Back to water.
A liquid. Back to a liquid. And it will start dripping out of this into your receiver. Now, let's just say that the boiling point of ethanol is 80 degrees. I mean, we're just going to say that. We're not going to quote that. We're just going to say that. Let's say it's 80 degrees. All right? I have no idea what it is. What if something starts boiling off here at 30 degrees? Is that ethanol? No. What about 40 degrees? No. You got this waste container here. Now, when this number gets up to 80, what do? You get rid of that thing and put you a brand new fresh one underneath that. So then what liquid's coming off at 80 degrees? That's your ethanol. That's the one you want to keep, right? Now what happens? It'll sit there for a long time, and then what happens when it goes to 82, 83, 84 degrees? Is it still ethanol? No. So that means you got to get rid of that and put the waste back up underneath there. All right, does that make sense to you? And now that's what's called a simple distillation. I mean, it's naturally the process is a lot more complicated, and you have to let it age and get flavors and all kind of stuff, right? But that's how it works. Now, you cannot get, using this method of distillation, you cannot get any greater than 190 proof, because it is impossible to take out 100% of the water using this method right here. You have to use, because there's something called an azeotrope in the way, you have to use other chemical means to completely dry it out. They ain't going to sell that in the liquor store. All right? It's just too expensive and too hard to get. So that's what they're going to sell there, is whatever's coming off of that container. Does that make sense to you? So when you go up in the mountains and you're walking along and you see some old man's moonshine still, a lot of times it's sitting right next door to a creek. He's got copper tube that's in the creek. Why is the copper tube in the creek? To keep it cool. It's got to have a place for when he's a-cooking for it to get cool and condense and run out. Does that make sense to you? Yes.
I have a question for you. My grandma used to do that, and I had to bring the water, and I never knew why did I need to bring the dirty water from the creek. But now I understand.
Oh, to keep the thing cool.
Yeah. But then she didn't have thermometer, but she would take the tablespoon and chirp a little bit, and then it's always a little container, but she would test it before she, runs
Did
it.
the whole thing.
Yeah. And then if it burns all the way, she puts the match on the table. If it burns all the way and it's dry, then it's good. So
Right, I'm
what
with
is
you.
the percentage do you think when it burns all the way?
Oh, if somebody was doing that, I mean, that's probably right around 85 or 90%. That's up there. Yeah. I'm sure she did it for medicinal reasons, right?
You're not
Yeah.
really
So,
She was cooking slow to get it that way.
yeah, cooking it slow, right? A slow cook on that one. So that would be the reason. Yeah, a lot of your old moonshiners, and that they really don't have glass thermometers and apparatus. I mean, they know what they're doing, but they do it by different methods. But are we good?
Distillers now, they do it with a vacuum. Like the vacuum, did they boil well?
Oh, to distill things? Oh, yeah. There's all kinds of distilling. Very complicated. There's things called fractional distillation. There's distillation you can do under a vacuum and rotovap distillation. I mean, there's just all kind of things that can go on. But, you know, be a chemistry major and learn about all that drama. Okay, how are we doing? Good? All right, it's 3:15. Let's take us a quick break. We'll come back and talk about something.
Is there a problem for this?
Yes, we're about to do some problems.